Hello, welcome back. So here we're picking right back up from our standard deviation that we just did with the birth weights. So once again, we're just going to go over this real quickly. We put the data set we had here at the very top in order to find the mean or median. Once we found the median depth, we reported that, and since they're already here, we then took the sum of all the values divided by the total number to get our average, so our x-bar, which was 6.81. And then from there, we went over the standard deviation formula and applied it exactly how the book shows us to do on page 92 and 93. I think it's a great way to set it up. It's very quick and fast. Once again, these units are actually squared. I was just trying to get through the video in time. I'm only allowed 15 minutes, so we were really close there. And then once we worked through the final problem, we found out our standard deviation was going to be 0.55 pounds. So now we found all parts of the mean, median, and standard deviation for this problem. So, all right, yeah, rules for rounding. So when rounding, we want to carry one more decimal place than occurs in the original set of values. Like I said, this is going to be a little different from maybe even past semesters. If you've talked to other students before, there is not a great way. You can go online and read a lot of information on how many decimals and rounding. Rounding is pretty simple as far as when to round. You only round at the very end of the answer. Don't round in the middle of the problem. The question is how many decimals to report. And so when we're reporting, we want to carry, once again, one more decimal place than what the original set of values has. So if we had, like in our previous example, we went one decimal place to the tens, we want to report in the hundreds. And a lot of times when reading this, we want to look at the data set itself. So if we're reporting in pounds and we're at less than 10 pounds, then it makes sense to go 2 decimals deep if we're reporting that. If we're talking something like dollars, or like hundreds and thousands of dollars or somewhere around there where we're using 4 or 5 significant figures, going decimals deep might not necessarily be advantageous for everybody to do. We're definitely being more precise and accurate to the measure, but to what degree is the question, right? Because it's going to take a lot more time to go many more decimals deep and write all that out. So we're going to be going forward and following the rules that are set forth by carrying one more decimal place than occurs in the original set of values, and we'll be carrying that through the rest of the semester. You'll see probably on a lot of the practice problems and other information, I go many more decimals deep. It's just a habit I have. I've always done it like this. And your answers and my answers should work out to be very similar. As long as you do not round in the middle of the problem and only round at the very end, our answers should be very similar to each other. I will just have more decimals deep. The book will sometimes also have decimals that you don't see, and that's just because of the space in the book. They can't have that much space dedicated to going so many decimals deep. So for us, and right now, our rules of rounding, pretty sure you've seen a video of me talking about this already, but we're going to carry one more decimal place than occurs in the original set of values. If you see me going more decimals deep, that is okay. If you want to go more decimals deep, that is also okay. Once again, as long as the information is in your notes or provided to me and I can follow the steps of what you're doing, I do double check a lot of stuff. If your answer is completely off from mine, I go in and look at your work and see where a mistake may have been made or what you did and the reason why it's so much different than mine. If I don't have work, I can't give partial credit. That's the bummer of all of it. So make sure you always just submit your work, and as long as everything is there, you will do fine. Once again, you always want to round as the last step of the operation. We want to avoid pseudo precision, and then when in doubt, if you want to look at APA publication manual, you can. Once again, you might be going down a wormhole and stuck on the internet for hours like I get sometimes when you're looking up exactly, because many people differ on how to actually report statistics. Some want more numbers, some say it should be less, and some people just don't agree, and so there's not a clear-cut rule. But one thing I want to do is just make everything consistent for the rest of the course. So these are the rules going forward. And then I always use common sense and good judgment. Like I said, if we're dealing with values that are super high, there's not a lot of reason to go 4 decimals deep other than to be ultra precise. But once again, does that make sense if we're talking about hundreds of thousands of whatever we're looking at? Maybe we're looking at like a viral load of HIV. If we're talking about viral loads of hundreds and thousands, does it make sense to have, decimals in there? Probably not when we're dealing with a number so large. But if we're dealing with very small numbers, then going more decimals deep would probably make more sense. So this is what I mean by using common sense and good judgment. So when we choose summary statistics, kind of to finish this all out, we always want to report a measure of central location, a measure of spread, and the sample size, at least. Next thing we want to do is if there's a symmetrical mound or the shape distribution, we want to report the mean and standard deviation. This is going to tell us a lot more than the other central location measurements. And then if we have an odd shape distribution, we want to report the 5-point summary or median IQR. This will tell us where the majority of the data will fall between and what kind of data set we are looking at here. Always a good rule of thumb. For me, it's always better to have more information than less information. So always definitely report, the mean and median and standard deviation, the spread. If you want a 5-point summary, that is great too. More information is probably not necessarily a bad thing for the purposes of our class. And then lastly, there are software and calculators that can be used. I will be having information up on graphing calculators. It is not required for the course to have a graphic calculator. However, I do highly recommend if you have one, pull it out, dust it off, get new batteries in it. If you don't have one, like I said, I don't recommend going out and buying one. I would literally post online and ask a friend. You probably know someone who does have a graphing calculator. Odds are maybe a cousin who graduated, or I don't know, but maybe not a cousin, but a friend. A lot of people have graphing calculators and they're just shoved away in a closet in a box somewhere and they're just laying there. You definitely ask to use it, ask to borrow it. I will definitely help you during the course of this course. Also, most people have Excel, and we'll be using Excel going forward for our data sheets. Excel can do a lot of these calculations on there. Our first data set isn't going to be till after the first exam, but I will have that up, and that will show you how to use Excel and how you can use Excel to do a lot of these calculations, especially for mean, median, mode, standard deviation. It can create box plots for you. It's a great tool that most people have and don't use. A lot of times you'll see in statistics books printouts for SPSS and SAS or Python R, which is a free software, and if anyone wants to use any of those and you know how to use them, totally use them. I'm not against limiting anybody. I will be showing how to use a graphing calculator, specifically like a TI-83, TI-84. TI-89s are a little different. If you have other calculators, definitely refer to the manual, and there's plenty of YouTube videos that show you how to use calculators. If you have even a TI, I believe like 30 XS, that can do standard deviation. It takes a little bit more steps to get it in there, but it can calculate a standard deviation for you. And I always think using a calculator is a great way to just double check your work. You can do everything by hand, submit it, and I can see the information. And then if you run it through a calculation, you can just double check it real quick. And if you have the same answer, boom, you're good. If your answers differ, well, it means one of two things, right? Either your math calculations on the paper were wrong, or you inputted data in the calculator wrong. Maybe they're both wrong, I don't know, but it is a great way to double check, and especially with a calculator, you can double check using a calculator. You can run a calculation 3 or 4 times, make sure you put the values in correctly and follow all the steps, and if you keep getting the same answer by putting it in from your handwork, then you know somewhere in the handwork there's something going wrong. Most common mistakes with standard deviation I always see are individuals, they forget to divide by n-1. For the degrees of freedom, they just divide by n. If you do that, then you're just, for standard deviation, you're creating the standard deviation of a population, not a sample, so make sure you always are following n-1. Another thing I see is sometimes people forget to take the square root. of the variance to get the standard deviation. And the next most common one is actually just adding. A lot of times when you're adding the squared deviations, sometimes you just fat finger a number in there, forget to type the right number because you're in a rush and you're trying to go quickly, and then that messes up everything. You might do everything right, but if you're supposed to put a 7 somewhere and you put a 5, that can really throw off the entire equation. So just make sure you slow down, double check, make sure you are putting in the information correctly, and you'll do fine. And then once again, always use software or calculators to double check your work. I think that's a great tool to learn. And that will now conclude this video, and I will see you all in the next one.